MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment on operational amplifier parameters and waveform generation using an IC ampic741. The aim of the experiment is to sketch and briefly explain an operational amplifier circuit symbol and identify all terminals, to list the amplifier stages in a typical op-amp and briefly discuss each stage, to discuss the op-amp modes and most important op-amp parameters, to measure the input bias current, input offset current, input offset voltage, input and output voltage ranges, the slew rate and bandwidth of op-amp. Operational amplifier is an 8-pin integrated chip. The pin configuration as shown in here, each pins have their own functionalities. Pin 1 and 5 are offset and null. Pin number 2 is used for inverting applications. Pin number 3 is used for non-inverting application. Pin number 4 is used to provide the negative voltage. Pin number 7 is used to provide the positive supply to the circuit. And pin number 6 is used to check the output. Pin number 8 is not having any connection. The symbolic representation of the op-amp is as shown in the figure. The stages of operational amplifiers are input stage, intermediate stage, and output stage. In the input stage, there are two terminals. One is inverting and another one is non-inverting terminal. Intermediate stage provides the balanced output to the level shifting stage. The level shifting provides the high voltage gain at low supply voltage. The output stage provides the output of the circuit. It contains complementary symmetry push-pull amplifier within it. The op-amp parameters are input bias current. The input bias current IB is defined as the average of the currents that enter into the two input terminals with the output at 0 volts. Typically, the input bias current is around 80 nanoamperes. This input bias current makes a voltage drop across the equivalent source impedance seen from the input side of op-amp. Input offset current. The input offset current is defined as the difference between the two input currents of the op-amp with the output at 0 volts. Typically, the input offset current for a 741 op-amp is 20 nanoamperes. Input offset voltage. In the ideal op-amp, when both inputs are at 0 volts, the output should be 0. Due to imbalances within the device, a small amount of voltage will appear at the output. This extra voltage can be eliminated by giving a small voltage called input offset voltage VOS to the amplifier. Typically, the input offset voltage for a 741 op-amp is around 1 millivolts. Slew rate. The slew rate is defined as the maximum rate of change of output voltage for a step input voltage. The slew rate makes the output voltage to change at a slower rate than the applied input. Eventually, the output waveform is a distortion of the input waveform. The typical value for the slew rate is 0.5 volts per microseconds. Bandwidth. Bandwidth of an amplifier is defined as the band of frequencies for which the gas remains constant. The bandwidth is approximately 1 MHz when the gain is 1. Let us set up the experiment to measure the operational amplifier parameters like input offset current, input bias current, output offset voltage as shown in figure 1. Let us start the circuit connection to show the other parameters like slew rate and bandwidth as shown in figure 2. After taking the readings of current and voltage, use the formulas for the calculations as shown here. After the calculations, fill the results as input bias currents in milliamperes, input offset current in milliamperes, input bias voltage or input offset voltage in millivolts, slew rate in microvolts per microsecond, and bandwidth in kilohertz.
Dear students, today I am going to execute the experiment of op-amp parameters and waveform generation of an op-amp using IC ampic741. So the main aim of the experiment is to find out what is the parameters of input bias current, input offset current and input offset voltage, bandwidth and slew rates. So the main components that require to exhibit this experiment is a signal generator. So this is the signal generator. This is the main power button to switch on the signal generator, and this is the on and off switch to exhibit the waveforms to the circuit board, and this is the monitor to display the waveform, and this is the sine wave, square wave, ramp wave, pulse wave, harp wave and noises that will be used to generate the signal to the input for the circuit. DC power supply. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have two main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have two main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we always keep this as a maximum current, and we have two main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Output oscilloscope. This is the digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as the channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. This is IC ampic741. This IC contains 8 pin. Okay, that will be start with the pin number of this notch. This is the notch that will be indicates the pin number 1. Okay, this is pin number 1, 2, 3, 4, 5, 6, 7, 8. This is the 8 pin IC ampic741. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is a series connection. So this is a series connection in x-axis, and this is a series connection in y-axis till this division that will be counted to 5. Till that it is a series connection. After that this is one connection. Multimeter that will be used to measure the voltage and current level in the circuit. Okay, and we can measure our resistance values here. So it will measures both AC and DC values. So this sign indicates the voltage that will be in AC. So this indicates the current that will be happen with the DC. This indicates the voltage we can measure in DC. So if you want to switch on this, you can turn like this. It will switch on to voltage or it will switch on to the required parameter. So we have two main terminals. One is a red wire and another one is a black wire. So the black wire is always in the ground connection. So red wire that will be shifted based upon our voltage and current values. that will be shifted to here or here. If it is a higher value, this wire that will be shifted to here. Okay, so these two terminals that will be used to measure the voltage and current level in the circuit. Patch cords. This is the patch cords that will be used to connect the input and output devices to the circuit. Connecting wires. These are all the connecting wires to connect the circuit. Now let us start with the experiment. So to measure the input bias current, input offset voltage and input offset current. Let us start the experiment connection based upon the circuit diagram. Okay, this is the 8-pin IC I am going to use. So this is the notch. This is the initiation of pin number 1 to 4, 5 to 8. Now I am going to connect with this in a circuit board. I mounted this IC to a circuit board like this. Now I am going to connect this DC regulated dual power supply to the circuit board. So now I am going to use the connecting wires to connect. So this is the connection for positive terminal. Wire. So now I am going to connect with another wire to negative terminal. So one positive and negative terminals will be created. So this will give us one voltage to one terminal. So on the same way we are connected in other side also to create positive and negative supply to the voltage, supply to the circuit. Based upon the circuit connection, I created two voltages VD1 and VD2. I connect the VD1 first. Okay, this is the positive terminal voltage. I am going to connect with the terminal number 2. Okay, 1 and 2 is the terminal. Based upon this notch we have declared. So this is the pin number 2. I am going to connect this wire. Okay, so next the black one I connected to ground. Okay, so this is the ground connection I made. In the same way I connect the positive terminal of VD2 to the terminal number 3. 1, 2 and this is the 3. I am going to connect somewhere here. In the same way I am going to connect this wire to the ground. Now you take the multimeter to measure the voltage and current level. So first I mount the positive terminal. The positive that will be connected to pin number 6. Okay, this is 5 and this is 6. I am connecting this wire to pin number 6. And this is the negative terminal. I made it to ground. The negative that will be connected to ground. So this is the ground connection. I am going to connect with the ground. This completes the circuit connection. Now let us switch on the DC regulated power supply. Now it will show us the voltage and current values that will be applied to the input. So now we switch on the multimeter to the voltage level because the output voltage level is 0. So now it is 0. You can tune this into 200 milli. Now, so this is the offset voltage I am going to measure. In the sense I need to manage the input voltage level to 0 output voltage level. Okay, so output voltage level is 0, but I need to maintain the two voltage levels, the maximum voltage levels, to make the output is 0. Okay, so that is our idea. So I am going to tune by using these fine tuners. You see the multimeter that will shows the 0 0. Again you increment like this in fine tuning it will show us 1. Somewhere it will changes 0.1 it will changes, but I'm going to minimize again to make it as a 0. See, 0 0. So this is our input, so it is 0.3 and 0.1. VD1 is 0.3 and VD2 is 0.1. So that makes the output VD is equal to 0, that is called as input offset voltage. This completes the input offset voltage measurement. Now I am going to connect the circuit for input bias current and input offset current. Now we will switch off the power supply. We have a small changes in the circuit. So to measure the current, we need to connect with a series. Okay, so that I am going to remove this multimeter from here in output end. So I taken one voltage terminal, positive terminal, and I remove the same negative terminal of the voltage. So I want to measure the current in the terminal 1. Okay, so I want to make this multimeter is in series connection with this voltage and this chip. So how I am going to measure, in the sense I am going to connect this negative terminal again to the ground. This is the ground connection. So positive I connected somewhere in the circuit. Now I am going to connect the positive terminal of the multimeter to series with the circuit. So this is a series connection. Now I am going to connect negative terminal that will be connected to the pin number 2. Here I connected the negative terminal. So that makes the series to measure the current in the terminal. Okay, now let us switch on the system. We are measuring the current. We need to tune the voltage to current. Okay, this is the microamp current I am going to measure. Okay, so it will show us some 120.3. so it is a 120.3 microamps that will be travels in a terminal 1. Switch off the system. In the same way we are going to measure the current in the terminal 2. So how to do? So we remove the connections of this multimeter, and I connect this VD1 to in the same position back to the terminal 2. The VD2 positive from the terminal I connected somewhere in the circuit board. I take the multimeter positive and I made it as a series with a VD2 terminal. So I take a negative terminal of the multimeter and I connected to the ground. This completes the circuit connections to find out the IB2 value. Now I am going to switch on the system. In the multimeter it will show us in the out of range. So I am going to tune this multimeter like this to milli. It will show some 4.2 milli. IB2 is 4.2 milli and our IB1 we measured previously as 119.8 or microamps. So IB1 minus IB2 gives the value of input bias current to the circuit. So we already measured the input offset current, input bias current and input offset voltage. Now I am going to measure the sleeve rate and bandwidth for the ampic741 IC. The two extra components I am going to use is this input device called signal generator, and I need to measure the waveforms by using the digital oscilloscope. Now let us start the experiment based upon the circuit connection. Take a breadboard, the IC that will be mounted in the same position. So I'm going to connect the saturation voltage to this IC by using DC regulated dual power supply. I connect this positive terminal to the pin number 7. 1, 2, 3, 4, 5, 6, 7. This is the pin number 7. I am going to connect this positive to here. Now I am going to connect this negative terminal to pin number 4. Okay, this is the pin number 4. I am connecting here. The connecting wire to make the ampic741 IC as a closed loop circuit. I connect this to pin number 2. This is pin number 2 I connected, and to pin number 6. This is pin number 6. I connected that into pin number 6. Now I take the probe to connect the input to the circuit. So I connect this probe to the terminal 1. So by using the wire, I connect this to positive, this to terminal number 3. You see the terminal number 3 is here. I am connecting this to terminal 3. Negative, I connect the negative to, I made the ground somewhere here. Okay, this is connecting the input terminal to the circuit. To measure the output, I am going to use the digital oscilloscope. I have to connect the digital oscilloscope by using 2 wires for each terminal, 1 wire. So I connect this one to here and this terminal to here. One is used to measure the input voltage and another one is used to measure the output voltage. So now I am going to connect the circuit to measure the input voltage by using this terminal like this. Okay, I connect the positive of the wire to pin number 3 here. So in the same way I am going to connect this output terminal to input terminal at pin number 3. This is the pin number 3 connections that is in series. I connected this into pin number 3. Now it connected to pin number 3. The negative terminal I made it as ground. Made as ground. So now I am going to connect the output terminal. So output terminal that will be measured at the terminal number 6. Now I am taking the wire, I connect the positive to the output terminal number 6. This is 5 and this is 6. I am connecting this into 6. And the negative terminal I made it as ground. Now it completes the circuit connection. So now you switch on the input signal generator and you switch on the terminal 1 to generate a waveform. You switch on the DC regulated power supply and that will be mounted to some 12 volt and you switch on the output device. Okay, you can set your frequency and voltage by using the signal generator here. So this is the frequency set and this is for amplitude setting. So you can set our frequency to 200 kilohertz, in the sense you can use these numbers 200. 200 we have one options called megahertz, kilohertz, hertz, etc. So you can click on kilohertz, it shows 200 kilohertz. You want to set an amplitude, you just go to the amplitude second button, press it and you type how much 1 volt peak to peak. Here we have option millivolt peak to peak, volt peak to peak, okay, milli VRMS and VRMS. So you can click on volt peak to peak, it gives 1 volt peak to peak 200 kilohertz. That will be happened with the, this is the output of slew rate. So this is the input signal, we are given 200 kilohertz 1 volt peak to peak. So the output that will be changes with the initiation period is changes with the input. Okay, so it will gives 1 volt peak to peak and 200 kilohertz with different time slots. Okay, see here, so it will be, so the period of this will start with some different time instant and this period will be start with different time instant. So this completes the experiment. So we can measure the bandwidth by using the formula and slew rate values.
At MSR UAS, we spark your imagination unlike any other.